Hello, my name is Abraham Ofori, and in this video, I will take you through solving exam practice questions on harmonic oscillator. Please like, comment, and subscribe to my channel if you haven't for more videos on such problems. Okay, let's start. A linear harmonic oscillator of mass 0.2 kg and spring constant 3 moves on a rough surface having resistance of 0.4 V, where V is the instantaneous speed of the oscillator and no other forces act on it. Okay, so you're supposed to find the damping factor of this oscillator. You're supposed to find if the oscillator starts from rest 5 meters from the relaxed position. You're supposed to calculate the amplitude after 1 second. Okay, so let's analyze some things here. Okay, a linear harmonic oscillator of mass, so the mass of the oscillator is what? 0.2 kilogram. The spring constant of the oscillator is what? 3. Now it moves on a rough surface. It means the movement of the oscillator would be impede or will be resist, the rough surface will be resisting it. It wouldn't make the movement be smooth, or it would like to make the movement not going on as we want. Okay, like it will be just reducing how fast you want to move. Okay, so this force or force of resistance is what we call the damping force. It is damping our um this in our oscillator. Okay, is reducing the speed that we want to go. Okay, so it is being caused by 0.4 V, and so we are supposed to use these informations to calculate all these questions or solve for all these questions. Okay, so let's start. Solution. Information given are mass, which is equal to 0.2 kilogram, the spring constant, which is equal to 3, the resistance force, which is equal to BV, and is given as what? 0.4 V. So you have to compare this. After comparing them, you see that B is what? 0.4. Okay. So for a damped harmonic oscillator, so this is damped. It is being damped by what? By the resistance force. Okay. The equation of motion is given by MA plus BV plus KX equals 0. Where all these we've been given them, the mass, the B, the K, we know them. Okay. So we want to write a general formula for this where A will stand alone. So we have A plus B over MV plus K over MX equals 0. And then we want to make this a linear without any fraction. Okay, so we let 2 gamma equals B over M and omega naught square equals K over M. So after putting these substitutions in, we get a nice linear equation like this. Okay, now where the gamma here that you are seeing is the damping factor and the omega naught is the natural frequency of the oscillator. Okay, so let's start with our problem. Now the damping factor gamma is given by what? Look, we said we substituted 2 gamma to be what? B over M into this equation. And so we just write that equation. 2 gamma equals B over M. We know our B, comparing this and this, we know B to be what? 0.4. So we write B 0.4 over 0.2. So 2 gamma is actually equal to this. Continuing with that, and we get 2 gamma equals 2. Point this on a calculator. 0.4 over 0.2 is 2. Hence our gamma is 1. Okay. Now therefore the damping factor gamma equals 1. Very simple, right? Okay, let's go to the second question. Yes, still information given are this, that, and that. But in the second sentence, if you could see clearly, this is what they said. If the oscillator starts from rest 5 meters from the relaxed position, so it means after it was started from rest. Okay, so if let's say we start from rest, when you start from rest, what is your velocity? You've not moved, so your velocity would actually be 0. And then before you started 5 meters from the relaxed position, so your actual position or your distance that you covered was 5 meters at time where you've not moved, you've not started. So at that point, time is equal to 0. the velocity at that point is also equal to 0, and the distance is being given, or the position is given as what? 5 meters. Okay, so take them and then you apply them. So the information given in the second statement is still, this is from the question. These informations are from the questions. Okay, the question gave us 0.2 kilogram, k to be 3, and bv to be 0.4 v. But the second statement gave us t time equals 0. Okay, and x of 0 at the relaxed position. Okay, no one has moved, so the time was 0. And then it means that when you evaluate the position vector or the distance vector x at 0, you get 5 meters. Then the velocity, which is the differential of the position, dx dt, is also equal to 0 at time t equals 0. Now, for a damped harmonic oscillator, we know the equation of motion is given by this. Then I put my masses, my k and my 0.4, whatever that I have in, and then doing so, I have a plus 2v plus 15x equals 0. But what is a and v in terms of? A is the acceleration, v is the velocity. So in terms of distance or the position, I can rewrite acceleration in terms of position. I can rewrite velocity in terms of position. So acceleration is actually the second derivative of what? The position. So the squared x dt squared with respect to time, plus 2 times the velocity is dx dt plus 3x equals 0. Okay, now here is the problem. Okay, we could actually use Laplace transform to solve this equation, but we don't want to use this because in some cases these conditions wouldn't be given, and we know that Laplace only works when you have initial condition given. So we want to get the knowledge about using method of undetermined coefficients to solve such questions, and then if you're able to do, we can solve every question under these kind of problems or this harmonic oscillator, because there are some questions that they will just ask you to solve for some part of the equation. You get the transient state and then the particular state, of which when you use Laplace you get it wrong. Okay, so let's learn how to use the formula or the method I'm coming to use. Okay, so using the method of undetermined coefficients, okay, you actually, since this is a harmonic oscillator, by all means the equation of motions will be a periodic function, because harmonic oscillator is actually a motion that deals with period. Okay, so we choose a periodic function or a power series, sorry, a periodic function like e to the power rt, which is this, and this we say that our x of t, we don't know it yet, we let it to be e to the power rt, a certain r times t. Then the x dt will be actually r e to the power rt, and the squared x dt squared will be this. So you just, the reason why you are choosing e to the power rt without choosing any other function is that for a periodic function, okay, we know that the functions can be, you know, sine x or cos x, those are the, or cos t or sine t. Okay, but we can actually write cos t sine t in terms of e to the power t using the complex numbers algebra that we know. Okay, so we just come here and substitute wherever we find our d squared x dt squared, we substitute in with what? R squared e to the power rt. Then you do same for the x dt, and we do same for x of t. Okay, now after putting it here, this is what we get: d squared x dt squared is what? R squared e to the power rt. Sorry, you put everything in, then you factor e to the power rt out, then you get what? R squared plus 2r plus 15. This is equal to 0. But we know that there is no way e to the power rt will be equal to 0. Why? Because this our time t is never going to be 0. It's never going, sorry, it's never going to be less than 0. Because if I'm calculating time, I'm not going backwards, I want to go forward. So what time will it take me to do is, okay, all right, so that is it. we don't say what is the negative, calculate the value of our x of t at time t equals -1. No, we say before or 1 seconds ago, something like that. So that is it. Okay, so we continue. As we are continuing, we just do send this side of the equation to 0. Like I said, will never be equal to 0, so we send the one that is inside this to be 0. Then we solve for our r, which r, when you find this on a calculator, r will give you -1 plus square root of 14i, or -1 minus square root of 14i. Now this r has given us two possible solutions. What do? We know that x of t is equal to e to the power rt, so we put whatever r here. Why? Someone will ask, why are you choosing only the positive side? Okay, this shows us that once you give us a complex number, it shows us that the solutions are indeed sine and cos, and so we just choose one of them and use it to work. Okay, all right. So s of t is equal to, again here I can multiply this through this and get minus t plus square root of 14 ti, and from indices this can be rewritten as what, e to the negative t times e to the square root square root of 14 it. When I compute this, I'll get what we had back. Okay, now in complex numbers I can just rewrite this as what, a cos square root of 14t plus b sine square root. The reason why we are bringing the a and b is because this, we know indeed we can rewrite this as what, square root of cos square root of 14t, then sine square root of 14t. But this a and b is telling us that the actual solution for our position, that is x of t, is actually in terms of some number multiplied by cos of this and some number multiplied by sine of this. Okay, so we don't, that is why we call this method of undetermined coefficients. We don't know the coefficients yet, so we'll be able to solve the equation generally by this. Okay, then you have to find the exact values of a and b that is generating this function. Okay, so you continue by saying, going back to our initial conditions given, that at time t equals 0, x of 0 is equal to 5. Then it means that if I put time t equals 0 here, when t is 0, here will be what, e to the power 0, which will give me 1. That is the 1 here. Then cos of 14 times cos of square root of 14 times t, where t is 0, I get what, cos 0. Cos 0 is 1, so I get a times 1 plus b sine 0. Sine 0 is 0, so I get this. And now this means that when I simplify this part, I'll get my a to be equal to 5. Very simple, right? Now we know that we can differentiate this to get our velocity this side. So dx dt is equal to minus, when you want to differentiate the whole of this, we can differentiate this. This is a product rule. This is like a function of t multiplying the whole of this. The whole of this is also a function of t. So I just differentiate this side and get -1 e to the negative t times the same thing, plus when you keep this one and you differentiate this. So it's like e to the negative t, then in brackets I differentiate this side. When you differentiate a cos root 14t, is like minus a root 14 sine root 14t. So you like, after different, this is how you differentiate this. You differentiate whatever that is here, you get, with respect to t, you get square root of 14. Then differentiate cos, you get negative sine. Then you maintain your constant. Okay, you do same for this side and you get b square root of 14 cos square root of 14t. Now we are saying that dx at time t equals 0, the velocity at that time is equal to 0 because it started from rest. That's what they said in the question. So hence, when I put 0 in place of t here, everywhere I put 0 here, I'll get what, 1, -1 here. Then when I put 0 here, I'll get a, only a. Okay, I get only a because cos 0 will give me 1, and it becomes a times 1, then plus sine 0, which is 0. So it becomes negative 1 times only the a part. Then plus this side, when I put 0 in, I'll get 1. Okay, I'll get 1 for here. Then sine 0 will give me 0. So this side will also go. Then cos of 0 will give me what? 1. So I'll be left with b square root of 14 times the 1 here. And that will be b square root of 14. Now, I try to simplify and solve for b. B is equal to 5 over square root of 14 since we know a. Then after that, we just write our main function or equation for x of t. Now, x of t is equal to e to the negative t into bracket 5 cos square root of t plus 5 over root 14 sine square root of 14t. So from here, we've been able to generate our function since we were given the initial conditions, this and this one. Okay. Now you can do further simplification by saying that s of t, if you have any number to the power negative 1, you can reciprocate it and becomes this way. Okay. If I push this through the whole of this equation, I'll get a nicer equation like 5 over e to the t cos root of 14t plus 5 over e to the t square root of 14 sine square root of 14t. Now the main question is you are supposed to find the amplitude, and then we know that the amplitude of a function containing both cos and sine is just the square root of the initials or the constants or the coefficients of cos and sine, squaring them, then you sum them. Okay, so it's the square root of this squared, this side squared, plus this side squared. Okay, this is it. This is the amplitude. Now they are saying that you should find the amplitude at 1 second. Okay, so a is equal, then you put t equals 1 in place of t, and simplifying this, we get something like this. And doing this after factoring 1 over e to the power squared out, you get 25 here plus this. Okay, so we simplify, and this is what you get after punching this on the calculator. You get something like, so the amplitude of the oscillator that we were dealing with is actually 5 square root of 210 over 14e. That's the answer. Okay, so let's move on to the second question. A linear harmonic oscillator having mass 2 kg has equation of motion given by d squared plus 1 d squared plus 1 all times x equals cos 2t, where d equals d dt and x is its displacement from the relaxed position of the oscillator at time t. So the oscillator starts with speed 2 meters per second and from the origin. Find the oscillator's position after 1 pi seconds and the kinetic energy of the particle at t equals pi seconds. So here is the case. Now, for our previous question, the right side of the equation was 0. This time it's not 0. So when you see such type of equations like this in harmonic oscillator, we use a different formula or a different format of solving it. So let's see the solution. Okay, before you can find the oscillator's position, you need to find a function x of t in general for it. Okay, now information given from the question is we've been given the mass, we've been given the velocity at time t equals 0 to be 2 meters per second. I hope you can see that from the question. And we've been given the position at time t equals 0 to be 0, because look, let's analyze it. They said the mass of the oscillator is 2 kg, and this is the equation. Now, and x is its displacement from the relaxed position of the oscillator at time t, and then the oscillator starts with speed. So the starting velocity, that is at the starting velocity where time equals 0, we have the velocity to be what? 2 meters per second. And it started from where? The origin. At the origin, we've not covered any position, we've not covered any distance. So the displacement or the distance or the position is 0. That's why we are saying that at time t equals 0, where you've not moved, the distance is 0, the velocity is this, and the mass is that. Now we have to expand this, just expand this one. Okay, and get this d squared x plus x. So d squared x plus x equals cos 2t. Now we know that d is what? D is what? D dt. So you come and put d dt in place of d, and you get what? D squared x dt squared plus x equals that. Now this looks like an equation of motion. So how do you solve this? Okay, like I said, you can use Laplace when initial conditions like these are given. Okay, but what if you don't have initial conditions? But let's use our method to solve it. So the solution to such problem where the right side of the equation is not zero is given by x of t is equal to sh of t plus sp of t. We are saying that when this side is not equal to zero, the other one that we did, this the right side of the equation was zero. Okay, but when this side is not zero, this is how you go xh of t plus sp of t, where sh of t is solving the left side as homogeneous. So you just take this part, this left side, solve it like we did in the first one, and call it the transient state solution. And then you pick the right side, you solve it, and it's called the steady state solution. So xp of t is solving the right side to get a particular solution. That's why we call the particular p. And sh is called the homogeneous solution. So solving the left side is transient state solution, and solving the right side is for the particular solution or steady state solution. Sometimes they just ask question, just solve for the steady state solution, and you can't use Laplace. Therefore, you know that d squared x dt squared plus x equals 0. This side, we pick this side and we are solving it like what? Homogeneous. So this solution will be what? Our transient state solution. So we solve this with our normal idea to get our sh of t, transient state solution. So we use the same idea and say that sh of t is equal to e to the power rt. Since the reason why we are not saying that s of t is equal to this is because this solution is actually for this part alone. So you have to just name it sh of t, and is equal to e to the power rt, and hence the x, you have to differentiate this. The xh dt is equal to r e to the power rt, and the squared sh dt squared is equal to r squared e to the power rt. Now having these, we just substitute these in place of this, right? Like we know. Okay, so wherever you see x, we put sh of t, and wherever you see the squared x dt squared, put the squared sh dt squared, which is given as this. Okay, now after putting it in, this is what we get: r squared e to the power rt plus e to the power rt equals 0. So we factor e to the power rt out like usual, then we get this, and we know that e to the power rt will never be 0, so we just equate this side to 0. R squared plus 1 equals 0, and hence our r is equal to plus or minus I. Okay, now for this, then this means that we stated that our sh of t is equal to e to the power rt. So r is what? Plus or minus I. So I said in the first example that you take just one, the positive part of it, the complex number, you take the positive part of it. So you take the plus I, and it becomes e to the power it. From complex numbers, I can write this as well. sh of t is equal to a complex numbers will tell me that this expansion, or this is the same as cos t plus sine t, or plus sine I, sorry, cos t plus I sine t. But this, in our solution, we said you just change them to the cos and sine, and you attach some coefficients, so that is a and b. So it become a cos t plus b sine t, right? Now this is the solution for the transient state, that or the homogeneous part. So we are going to the particular part. So we are saying that the reason why we are writing this here is that, look at this. We are saying that you have a certain function. Okay, when you differentiate it 2 times plus the original function, you get cos 2t. And functions that when you differentiate, do your manipulations, you can get cos 2t's. The function should be of the form either sine or cos. And what angle should we do, or should we use? The angle here is 2t, so it means you should use either sine 2t or cos 2t, but we don't know it yet. So we write it in terms of the combination of the two of them. So we are saying that our particular or our original solution, that is what we call the particular solution, is equal to a certain constant c1 cos 2t plus a certain constant c2 plus, sorry, sine 2t. Okay, then I differentiate it and I'll get what? Minus, when you differentiate this one, you get negative 2 c1 sine 2t plus 2 c2 cos 2t. I differentiate it again. The reason why we are differentiating is in our original equation, there is a second derivative in it. We need to find all the derivatives if this is our main equation that we are saying. So you differentiate this again and you get minus 4c1 cos 2t minus 4c2 sine 2t. Okay. Now, putting in the original equation where the equation was this, okay, d squared x dt squared plus s equals cos 2t. So wherever you see d squared x dt squared, you put d squared sp dt squared, which is this. And then wherever you see x, you put xp of t here. Okay, we put it here. This, after putting it in, this is what we get. This side, which is the second derivative, you can and put it here, plus without the derivative. Okay. Then you compare coefficients. After doing the summation, there's a negative 4 c1 here cos 2t is plus c1 cos 2t. So I can combine this and get negative 3. Then the same thing happens to the sign. Okay, so I get negative 3 c1 cos 2t minus 3 c2 sine 2t equals cos 2t. Now I just compare coefficients. Okay, sorry, if this is equal to that, then it means there is actually a certain plus. There is no sign component here, so it means the I just compare coefficients on both sides. Okay, so minus 3c1 should be equal to the coefficient of cos 2t, which is 1 here. Okay, that is the case. And minus 3c2 should be equal to the coefficient of sine 2t. There is no sine 2t, so it will be what? 0, right? So here c1 is negative 1 over 3, making it the subject here. And like I said, negative 3 c2 equals 0. This means that c2 is equal to 0. Okay, now it means that my xp of t, which is equal to the xp of t, we are saying that is equal to c1 cos 2t plus c2 sine 2t. I just substitute my c1 and my c2 in this, and after doing that, my c2 is 0, so I'll get only the cos 2 part. So I get xp of t to be what? Negative 1/3 cos 2t. Now it means my x of t, which is equal to the summation of the solution at the transient state plus the solution at the what? The particular state or the steady state. This is equal to x of t is equal to a cos t plus b sine t minus 1 over 3 cos 2t. The reason why we are maintaining our a and b is because we can't solve them from the transient state. You have to write, mind you, we said x of 0 is equal to 0. Okay, x of 0. So we didn't say sh of 0, we said s of 0. So we need to find our main s of t, then use these conditions on them to find our a and b. So we know that the velocity, which is ds dt, is equal to 2 meters per second, and at time t equals 0, that is only when you get this. And at that time, x of 0 or s of time t equals 0 is equal to 0. So in case of that, if I put my 0 here, it means everything here is 0 when I put t to be 0 in this. So let's put t to be 0. A cos 0, it becomes what? A cos 0 is 1. B sine 0 is what? 0, so it becomes 0. Cos 2t, 2 times 0 becomes 0, so cos 0 is 1, so it becomes minus 1 over 3. And you are saying that at that time t equals 0, the whole solution here is equal to 0. So I make a the subject and I'll get a to be what? 1 over 3. Now I differentiate this function to get my dx dt, and this is equal to minus a sine t, because when I differentiate this, you get minus sine, plus b cos t minus, sorry, it becomes, the cos will give you minus, but then there's a negative sign here, so it becomes plus 2 over 3 sine 2t. But we know that at time t equals 0, dx dt of 0 equals 2. So I'll put 0 here. Come, let's see. Sine 0 will give me what? 0. So this part will go. Sine 2, 0. 2 times 0 becomes what? Sine 0, which will be 0. So I'll be left with b cos 0. Cos 0 is 1, so I'll be left with b. And we are saying that after simplifying all these, at that time t equals 0 is equal to 2. So it becomes b cos 0 is equal to 2, and cos 0 is 1, so I get b is equal to what? 2. This is clear, right? So my main s of t is given as 1 over 3 cos t, which is a, plus 2 sine t, which is b, this 2, minus 1 over 3 cos 2t. So this is our general, or this is our main solution for position of the particle at any time t. So the first question was, you're supposed to find the position of the particle at time t equals what? Pi seconds. So at pi seconds, x of pi is when you put pi inside these. So cos pi is what? Cos of 180. And cos of 180 is negative 1. Sine pi, sine of 180 is 0. Cos 2 pi, cos of 360 is 1. So you put everything in. And so this cos pi is negative 1, so it becomes negative 1 over 3. Then this becomes 0, this side. And this is what? Cos 2 pi is 1, so it becomes negative 1 over 3. And summing this, I get negative 2 over 3. So the position of the particle at pi seconds is equal to negative 2 over 3. Now the kinetic energy at time t equals pi seconds. Okay, we know that kinetic energy is equal to what? Half mv squared. So we are supposed to find our velocity from this equation. Okay, now our velocity is, which is equal to the differential of this with respect to time, dx dt is equal to, differentiate the whole of this with respect to time, becomes negative 1 over 3 sine t plus 2 cos t plus 2 over 3 sine 2t. All right, so after that, what do? I know my mass, but at the time t equals pi seconds, my velocity is what? Put pi seconds here, sine of 180, 0. Here will be 0, because 180 is what? Negative 1. So we become negative 2. Sine of 360 is 0. So I'll get negative 2. Velocity at pi seconds equals negative 2. My ke is equal to what? 0.5, that is a half, times the mass. Mass was given in the question, which is 2 kilogram, times the velocity squared. And this half will take care of this 2. I'll be left with negative 2 squared, which is 4 joules. So that is the solution to the question that we're given. Sorry, this is the question. Okay, so that's the solution to the question. Okay, look at how the process that we pass through to get all these. Okay, these are the main questions you are supposed to solve, but you are supposed to pass through a whole lot of process before you can get this. All right, so thank you, and please subscribe once again if you haven't, and see you next time. We'll solve different types of questions on this topic before you get to write any exams on a topic you are doing. And then I hope you understand or you understood this. If you want me to do any video on any topic, you can comment it on the comment section, and I'll be very glad.